is just building on to what you've already done in A1 and A2. The one thing that they focus on is your ability to tell right away from the equations whether you have one solution, unlimited solutions, or no solution. So there's a quick way in which we can tell that. So if you look at the page 178, two lines that have different slopes will have one solution. Okay? They have different slopes, they'll have one solution. If they have the same slope and different y-intercepts, you'll have zero solutions. Why? Same slope, different y-intercepts, what does that mean? They're parallel. So they never cross each other. Okay? The third is if they have the same slope and the same y-intercept. What does that mean? They're the exact same line. So what you have to do to determine that is try and find the slope of it in the lowest terms possible to see if they're the same or not. Okay? Because in the two circumstances, if they're the same, then that either means they're parallel or they're the exact same line. So that's the first thing that you need to identify. So looking at the two equations here, three x minus y minus 4 equals 0. Well, I don't think that's right. Judging by the equation, it should be equals 4, I'm guessing. Sorry, misprinting the book. Yeah. Okay, and then 6x minus 2y. So when I look at it like this right now, it's a little more difficult to tell or determine whether or not I have one solution, multiple solutions, or no solutions. Okay? So the easiest way to do that is to actually put it into y equals form so that we can find the slope and the y-intercept. So in this case here, I'm going to add y to that side. And I'm going to subtract 4 to the other side. And there's my equation. Y equals 3x subtract 4. What's the slope of that line? 3 over 1. Again, how do we determine slope? Where is it located? In front of the x. It's the number that's in front of the x. Right? What's the y-intercept in this case? -4. So I have a slope, 3 over 1, and a y-intercept of -4. All right, so let's arrange this guy now. I'm going to subtract the 6x to the other side. All right, and how am I going to get y by itself now? Divide by -2. Y equals 3x plus 9 over 2. What's the slope of this guy? 3 over 1. What's the y-intercept? 9 over 2, or 4.5. Agreed? Okay, so I have two lines, same slope, different y-intercept. How many solutions? None. Why?
Because they're parallel.
They're parallel to each other. If the slopes are the same and the y-intercepts are different, you have parallel lines, there's no solutions in this. Okay? The symbol for this, that'll work. No solution. Or write no solution, whatever you want to do. Okay? So there's the first aspect of 8.3. The second is your ability to make your own equations and then simplify and solve them. 4 students are going to type the same lengthy essay. Shauna begins first. Anna and Christian start together a short time later and type at an equal speed that is faster than Shauna's rate. James begins last and types at the same speed as Shauna. The number of words typed by each student as a function of time could represent by a linear equation. How many solutions should there be for each system of linear equations? All right, so they're not even asking you to do it. They're asking you to use logic right now. Think this through and use logic. Okay? So there's first things first. Shauna begins first. So we'll put them in order. So Shauna goes first, right? Anna and Christian start together. And who goes last?
Shane.
Shane? Shane. Thank you. Oops. Shane goes last. Okay?
James.
James. Let's try that a third time. Alright. Okay, so now it says Anna and Christian start together a short time later and type at an equal speed that is faster than Shauna's rate. So these two are going to have a faster rate. What tells us the rate in an equation?
Slope.
The slope. So these two have the same slope. And their slope is faster or steeper than what Shauna's is. Right? So at some point, the longer we go, eventually what's going to happen?
They're going to pass.
They're going to pass Shauna, right? So where they intersect, okay, there'll be one intersection point. Will these guys ever intersect?
No, because they're the same line.
It's the same line, so it's an infinite number.
Say that again.
It's the same line, so they
Yeah. They have the same slope, but they also start at the same time, so that means that their y-intercept would be the same. Okay? So these two are going to have an infinite number of solutions. Okay, and what happens with James? He types faster than who? Shauna? Is that right?
Same speed. Same speed.
Same speed as Shauna. So what's going to happen with Shauna and James? So we're going to look at those three scenarios, right? Okay, Shauna and Anna. How many solutions between these two?
One.
One solution, right? Because she has a different slope than her, and they start different times. Anna and Christian, infinite number of solutions. They're exactly the same line, same slope, same y-intercept. What about Shauna and James?
No solution.
What's going to happen?
They're parallel.
They're parallel, that's right. Okay? They have the same slope together, but they start at different times. So he's never going to catch up, right? Okay, so that's just pure logic, what we just did there. Okay, using a little bit of math intuition, but it's logic. What's going to happen? Okay? Now, let's quickly go through 1A and 1B. Predict the number of solutions for each system of linear equations. Justify your answers. Y equals 4x minus 1 and y equals 4x plus 7. How many solutions?
No.
None. Right? Parallel lines. How about B? Y equals 3x plus 5. Y equals negative 3x plus 5. One solution. Where's that solution? So if I'm asking for a solution, I'm asking you for a coordinate, right? Where's that coordinate that they're going to meet?
0 and 5.
What is it?
0 and 5.
Oh, O is a letter.
Same thing.
Same thing as what?
0.
Capital O and 5? Okay, 0 and 5, exactly, right? That's exactly where they would meet, 0 and 5. Okay, so that's basically the gist of 8.3. You just are going to try and find the slope, the y-intercept, and tell me the number of solutions. Okay, whereas 8.1 and 8.2 that you worked on yesterday, and the day before, and the day before that, all right, you're actually having to find out what the solutions are. Okay, so you have to write out the equations, find out where they cross at, and go from there. So the next order of business is let's look at those questions and answer any of the questions that are in there. You had probably 1 or 2 more days than you needed to work on it, so there had better be a couple questions in there. Okay, so page 172, question 4. Solve each system of linear equations by creating a table of values and graphing with pencil and paper. Okay, so y equals 8x minus 3. Y equals 2x plus 3. Alright, so table of values. They want you to graph this in the table of values. Table of values implies you can put whatever you want in for x and solve for y. What is the minimum number of coordinates you need in order to graph a line? 2, right? As long as you got 2 points, graph a line. So you can have 2 values there and that's all you need. You can have 10 values, but then you got to draw a line. Okay? So we'll just pick 0 and 1 and 2. Random. Random. Okay? Doesn't matter what I put in there. Still going to get 2 coordinates because I'm going to put it into here. This is my output. This is my input. I'm going to input 0 in for x, and it's going to spit out a y, which is my output. Right? 8 times 0 is?
0.
0 subtract 3?
-3.
-3. Put 1 in for x. 1 times 8. Subtract 3?
5.
2 times 8? Subtract 3? 13, sure. Okay? There we go. Alright, same thing. 0, 1, 2. We'll put the same coordinates in. Or same x values, not coordinates, but same x values. 0 times 2? 0. 0 plus 3?
3.
3. 1 times 2?
2.
Plus 3?
5.
2 times 2?
4.
Plus 3?
11.
Okay, so I've got 3 coordinates in each. So all I have to do now is plot those coordinates on the graph and find out where they intersect at. Okay, so I'm going to graph this using my trusty program here, twice, in fact. Okay, so what's the first equation? 8x subtract 2?
3.
Subtract 3, thank you. There's graph number 1. Y equals 2x
Plus 3.
plus 3.
Yeah.
Thank you. Plus 3. Graph number 2. So a bit of grid. Too many of those. All right. So first coordinate 0, -3, and then 1, 5. Let's check that on here and see what we got. 0, -3, right here. There's the first coordinate we graphed. 1, 5 was the next one. There's a special one. Okay. Then on the other one we went what? 0, 3 and 1, 5 again. Okay. So the whole point of the exercise, what was it? 0, 3
Yeah. And then 1,
Yeah.
5.
and 1, 5. The exercise said create a table of values and find out your solution. Looking at the table of values, what's your solution? Which one has both coordinates in it? 1 and 5. Right? That's without graphing. That's without solving using algebra. All that was a table of values created, a random table of values, no less. I just picked 0, 1, and 2, and it just happened that when I did 0, 1, and 2 for this, we ended up with the same solution. One of the things that you have to do a better job is, if you create a table of values and you mark off your coordinates on here, okay, it'd be another coordinate down here, right, and another coordinate right here. So if you mark off those coordinates, this is a line. You must draw arrowheads on the end of it. It's a line. Same thing over here. Draw your arrowheads. Once you've labeled all your points that you want on here, you can label as many as you want or as few as you want. Okay? You label it. That's your line. Draw a line through it, And then your intersection point, if it's a question that's asking you for it, I circle it. Circle your intersection point and write the coordinate out. There's your answer. Okay? This does not have to be complicated. Alright? Okay, there's question 4. Other questions?
Question 8 on 176.
76? Okay. Highest point in Alberta is Mount Columbia. The highest point in Saskatchewan is Cypress Hills. Their elevations are related by the system of linear equations. I keep saying linear equations. So the first one is A minus S equals 2279. The second one is A minus S is equal to,
A plus S.
what is it, sorry?
A plus S.
A plus S times
And 5,215.
5,215?
Yeah.
Okay. All right. Where A is the height in meters of Mount Columbia above sea level, and S is the height in meters of Cypress Hills above sea level. So explain the meaning of each equation. So what is the meaning of each of these two equations? What is A again? What is A?
Like the height. Mount Columbia above sea level.
So it's the height of Mount Columbia above sea level. And then I'm subtracting the height of Cypress Hills above sea level. Which is the higher of the two? Which one has a higher peak? Cypress Hills or Mount Columbia? Right. So the fact that when I take whatever the height is, we don't know what it is, of Mount Columbia, and I subtract the height of Cypress Hills, it gives me a positive number, which means that that's got to be higher, right? And the combined height, that's what this is, the combined height above sea level of both of them is this number right here. Okay, so far, Zach? Right? Rewrite each equation to isolate the variable s. Okay, I want to solve for s. How do I get s by itself here? What?
Yeah, subtract.
Okay, so I'm going to have negative s is equal to negative a plus 2,279. But I have to isolate s. Do I have s isolated?
No.
No. What do I got to get rid of?
The negative sign.
The negative sign. How do I do that?
Divide by negative 1.
Divide by negative 1 or times by negative 1. So there's the first one. So s is equal to a minus 2279. Right here. Negative a plus 5,215. Okay, so far. Graph the equations together and determine the heights of Mount Columbia and Cypress Hills. Well, I'm not going to graph them. I'm going to do something different. Okay? I could graph them, but then I'm going to have, it's tough to graph that on graph paper. So I showed you this before. This is something you're more than capable of doing. This is what s equals here and s equals here, which is the height of Cypress Hills. So to find Cypress Hills, I either take Mount Columbia's height and subtract 2279, or I can subtract or take the negative of Mount Columbia and add it to 5215. So that's what s is. So the s's are equal to each other, which then means then that a minus 2279 is equal to minus a plus 5215. All right, s is the same value in both. Okay, so therefore, if that's what s equals here and that's what s equals here, I can plug those in. So now let's solve for A. Let's put the A's on one side and the numbers on another side. So I'm going to move that A over by adding it. What's A plus A? 2A minus 2279 equals 5215. How do I get 2A by itself? Add 2279. So 2A is equal to, add that. I need a calculator for that one. Or do I? No, probably not. 94, 7494, I think. Okay? Now, solve for A. How high is Mount Columbia? Above sea level. So great.
47.
47? There you go. So now I know where the A value is, where they're going to intersect. So I put it in here to solve for S. Where's S?
4,168.
Yeah? Okay. Back here for 1 second. What's the dependent variable there? What's the dependent variable in this equation, the way I've written it? Why do you say that?
Because S is depending on what they.
Absolutely. You're 100% right. Can't say it any better. This is the dependent variable right here because it's dependent on whatever A is. I can't find S without finding A. So the way I've written it, that's like saying y equals negative x plus 5215. All right? S is dependent on A. Therefore, to write this as where it's going to be as a coordinate, it's going to be this. There you go. There's the coordinate, there's the section, there's where they're going to intersect at. All right? Now, if you graphed it on some sort of technology, that's what you would get. You find out where they intersect at. So, if you were to draw a picture of Cypress Hills and Mount Columbia, Cypress Hills would be greater on the way up until you hit this amount above sea level. And then, if Cypress Hills is S, right? So 1468, and then Mount Columbia becomes bigger than it at that point. It'll always be higher than it. Okay? Anything else from 8.1 and 8.2? Now, I can't stress the importance enough of being able to graph and solve these questions. Because as we get to grade 11 next year, you're going to get something like this. You get that. Y is greater than or equal to 8x minus 3. So what happens in that question is you get more solutions than even what was on the line. All you're solving for is every solution that's on the line. If I solve for this guy in the form that it's in right now, okay, it means that it's every solution greater than the line. So how does that look? Well, I'm going to clear this off. What happened? It's the same graph I punched in, except all I did was switch this to greater than or equal to. All right? So what I've done here is I graphed that line. See, my line hasn't moved. Still the same line. But now, not only are all the points on this line for that equation, but every point in here also satisfies it. Because they are all of these are greater than that value. So if I take this coordinate right here, which is 0 and 0, 0 is greater than, so that's 0 subtract 3, negative 3 is 0 greater than negative 3. Yeah, that means I gotta shade over it. This is next year. So where does this all begin? In order to get to here, you have to be able to draw that line. Otherwise, you'll struggle with this next year as well. And then from there, we get into quadratic equations, parabolas, in which you've got to do the same thing. You've got to be able to get this down pat. So for the next couple of days here, your focus needs to be on, can I draw a line? And it doesn't matter if you do slope-intercept form, if you do your intercept, 0 and 0, if you do a table of values. You have to be able to draw a line between two coordinates. If you can't, this isn't going to go well for you next year. And it's a part of the applied course, as well as the pre-calculus. Okay? All right. You got the rest of today.